In unit number 4, we are learning speed and velocity. So what is speed? It is a common term in daily life. When you drive a vehicle, sometimes you are moving fast, moving slowly. So that refers to speed. So what do you mean by speed? Speed is generally calculated by the equation distance divided by time. Distance divided by time. So it is a ratio between distance and time. Speed equal to distance by time. So when you can say the object is having more speed, that means if the object covers a long distance in a short time, then the object is moving with a high speed. When you can say the object is moving with a low speed, when the object takes short distance by taking long time, you can say the speed is less. So speed always calculating with distance and time. So distance is represented by d and time is represented by t. So you can calculate speed, you can remember like this. Speed is distance by time. Speed equal to distance by time. In order to calculate distance, you hide d, that is speed into time. Or in order to calculate speed, you hide s, that is distance by time. In order to calculate time, you hide t, then time equal to distance by speed. If speed equal to distance by time, distance equal to speed multiplied by time. So in order to calculate distance, you hide d, okay, then speed multiplied by time, that gives distance. In order to calculate speed, you divide distance and time. In order to calculate time, you hide t, that is distance by speed. So which are the equations? So speed equal to distance by time, or distance equal to speed multiplied by time, or time equal to distance by speed. So these are the three equations. So in different problems they are asking different values. If you want to calculate time, time equal to distance by speed. If you want to calculate distance, that is equal to speed into time. If you want to calculate speed, that is distance by time. So these are the equations. By using these equations, you can calculate different values. So what is speed? What is speed? It is a ratio between distance and time. It is a ratio between distance and time. Then is it a scalar or vector quantity? Is it a scalar or vector quantity? So from the equation you can clearly see speed is the ratio of distance and time. Distance is a scalar quantity, time also a scalar quantity. So speed is a scalar quantity. Speed is scalar because speed is derived from two scalars. Speed is derived from distance and time. They are scalars. So speed is a scalar. Then what is the normal unit for measuring speed? You know that distance is measuring in meter. Distance is measuring in meter and time in seconds. So it will be meter divided by second. So the normal unit for unit of speed is meter per second. Meter per second is the normal unit for speed. Normal unit for speed is meter per second. In some problems they will give a unit kilometer per hour because we are calculating the speed of the vehicle in terms of kilometer. Kilometer per hour. How will you convert kilometer per hour to meter per second? How can you do it? For example, 36 kilometer convert into 36 kilometer per hour, convert into meter per second. So how can you do it? 36 multiplied by kilometer, convert into meter. 1 kilometer is equal to what? 1000 meter. So multiplied by 1000 meter. Then 1 hour is 3600 second. 3600 second. So when you divide, so now it is in meter per second. So you can cancel 2 zeros. Then you can cancel with the 5. So 5, 18. So you can write simply as 36 divided by 18 by 5 meter per second. You are taking 5 in the denominator, it will be 18 by 5. So 18 by 5 is 3.6. 18 by 5, if you calculate, it is 3.6. So you can simply write as 36 divided by 3.6 meter per second. So in order to calculate kilometer per hour to meter per second, you just divide the number with 3.6. You just divide the number with 3.6. So that is the way of conversion. So if you want to calculate 36 kilometer per hour to meter per second, how will you convert? 36 you just divide with 3.6 and multiply with 10, here also with 10. So it will be 36 multiplied by 10 divided by 36. 36 cancel. It will be 10 meter per second. 10 meter per second. So when you calculate kilometer, or if you want to convert kilometer per hour to meter per second, just divide with 3.6. Just divide with 3.6. That means 36 kilometer per hour and 10 meter per second. They are same, but the units are different. One is in kilometer per hour and another is meter per second. So in some numericals, the speed of the object they are giving in kilometer per hour. How will you convert into meter per second? Just divide by 3.6. If you want to convert meter per second to kilometer per hour, how will you convert? Multiply with 3.6, just opposite. So you will get kilometer per hour. So if you want to convert kilometer per hour to meter per second, divide with 3.6. If you want to convert meter per second to kilometer per hour, multiply with 3.6. So these are the conversion factors. So in numericals, normally the speed of the vehicle they are expressing kilometer per hour. So you must convert into meter per second by dividing the given number with 3.6. If the values are given in meter per second, if you want to convert into kilometer per hour, you just multiply the number with 3.6. So these are the conversion factor. So when you do numericals, you must always use meter per second. The speed of the unit is always we are using meter per second. Next, what do you mean by average velocity? Sorry, average speed. Average speed. It is a simple equation. Average speed equal to total distance divided by total time. Average speed you can calculate by using a simple equation. It is the total distance divided by total time. It is the ratio of total distance and the total time. That means by using an example, you can simply express it. Average speed. You are moving from A, B, C, D. A to B, for example, 3 meter. B to C, 2 meter. And C to D, 4 meter. and you are taking a time here 4 second, here 2 second, here 3 second. Then what is the average speed here? Average speed equal to total distance A to B, it is 3 meter, plus B to C, it is 2 meter, plus C to D, it is 4 meter. So this is the total distance. Then total time, that is 4 plus 2 plus 3, equal to 3 plus 2, 5, 5 plus 4, 9, divided by 4 plus 2, 6, 6 plus 3, 9. That is, here it is 1 meter per second. So the average speed calculated by total distance divided by total time. So when you move from one place to another, you are traveling, you are covering different places. You are moving from Umtata, then East London, then you can go Port Elizabeth. So from Umtata to East London there is a distance, and East London to Port Elizabeth another distance. So for covering these distances you are taking different time. So take the total distance and total time and take the ratio of that, you will get the average speed. Average speed you are expressing in meter per second. Next, another quantity we are explaining is velocity. It's a new quantity, velocity. Velocity simply means displacement divided by time. Displacement divided by time. Displacement divided by time. Instead of distance, we are using displacement. So what velocity is equal to displacement divided by time? It is a ratio of displacement and time. What is its unit? Normally, the normal unit for measuring velocity is meter per second, because we are explaining or we are measuring displacement in meter, time in second. So it is a meter per second. Its unit is meter per second. Is it scalar or vector? Next question is it scalar or vector? Velocity is scalar or vector? It is a vector quantity. What is the reason? It is derived from a vector quantity. Displacement is a vector quantity. So velocity also will be a vector quantity, because velocity is derived from a vector quantity. So that's why velocity is a vector quantity. So velocity simply means displacement divided by time, and it is measured in meter per second, and it is a vector quantity because it is derived from a vector quantity. Then what do you mean by average velocity? Average velocity. Average velocity equal to total displacement divided by total time. So here, instead of taking total distance, we are considering the total displacement or simply displacement. So average velocity equal to total displacement divided by total time. Average velocity is also a vector quantity. It is measured in meter per second. By doing a simple problem, you can understand what is the difference between average speed and average velocity. The same one we can take it A, B, C. For example, this is 6 meter, this is 4 meter, and this 8 meter. 8 meter. Here you are taking 4 seconds to travel. Here you are taking 2 seconds to travel, and here you are taking 3 seconds to travel. So from A to B, the distance is 6 meter and taking time 4 seconds. B to C, distance is 4 meter and taking time 2 seconds. From A to C, it is 8 meter distance and you are taking 3 seconds. Then, what is the average speed here? Total distance. That is total, it is a ratio of total distance and total time. Total distance from A to B. A to B distance is 6 meter plus B to C 4 meter. Then total time 4 seconds plus 2 seconds. So it will be 10 meter divided by 6 seconds. That is the average speed. Then here, what is the average velocity? Average velocity. So you know that what is the displacement in this motion? Initial position is A, final position is C. So the shortest path is A to C, AC. Its value is 8 meter. So 8 meter divided by, what is the time for it? 3 seconds. So for this average velocity is 8 meter divided by 3 seconds. Both are different. Average speed and average velocities are different. Initial position of the object is A, final position of the object is C. But their average speed and average velocities are different. What is the reason? For calculating average speed, you are considering distance, and for calculating average velocity, you are considering total displacement or displacement. So that's why they are different. One thing you have to remember, if an object is traveling along a straight path A to B, if an object is traveling along a straight path without change in direction, if an object is traveling a straight path without change in direction, then in that case distance will be equal to displacement and speed will be equal to velocity. Because distance simply is displacement. Both will become equal. Distance and displacement, they are becoming different because of the change in direction. Speed and velocity, they are becoming different because of the change in direction. If there is no change in direction, distance and displacement, they are same. Speed and velocities, they are same. So if an object is traveling along a straight path or traveling along a straight road without change in direction, distance and displacement, they are same. Speed and velocities also will be same. They are become different. They will become different. They will become different if there is a change in direction. So if after B, if the object is changing direction, then when you calculate distance and displacement, they are different. When you calculate speed and velocity, they are also different. So if there is no change in direction, and if the object is traveling along a straight path, distance and displacement, they are same, and speed and velocities also will be same. So this thing you have to keep in mind. You have to remember this thing. Another example for calculating average velocity and average speed. An object is moving from A to B, then C. For example, this is 5 kilometer and this is 3 kilometer. For traveling 5 kilometer, the object is taking 1 hour, and here it is taking half an hour. So it's an example problem. So what is the average speed here? Average speed equal to total path 5 kilometer plus 3 kilometer. Then what is the total time? 1 hour plus half an hour. This will give you average speed. Then what do you mean by average velocity here? What is the change in position? Here the object, this is the initial position of the object, this is the final position of the object. Then what is the change in position? Change in position is this much only. From A to C, this is the change in position. That is 5 kilometer minus 3 kilometer. 5 kilometer minus 3 kilometer. So from A to C, that is the change in position of the object. Initially it was at A, finally at C. So the change in position is, it is expressed in 5 kilometer minus 3 kilometer, that is 2 kilometer. Then what is the total time to reach C? Total time will be same, that is 1 hour plus half an hour. So these are the average speed and average velocity in this motion. So from A to B, 5 kilometer taking 1 hour, then B to C, 3 kilometer taking half an hour. So when you calculate the average speed, you are considering total distance and total time. When you calculate average velocity, you are considering only displacement. Displacement is change in position. Initially at A, finally at C. Change in position is AC, that is 5 kilometer minus 3 kilometer, that is 2 kilometer. But the time will be the same. Total time will be for reaching C, that is 1 hour plus half an hour. So for this case, average velocity and average speed, they are different. So this is a good example for understanding average velocity and average speed. In unit number 5, we are learning a new quantity, but it is familiar to you. It is acceleration. Acceleration. Acceleration you are normally deriving from velocity. Acceleration is normally change in velocity. Change in velocity divided by change in time. Change in time. Acceleration is change in velocity divided by change in time. So acceleration is derived from a velocity. Acceleration is derived from velocity, so it is a vector quantity. So it is derived from velocity and time. What is the unit of velocity? That is meter per second. Then what is the unit of time? That is second. So the unit of acceleration is meter per second divided by second, or meter per second square. Meter per second square is the unit of acceleration. Meter per second square is the unit of acceleration. And acceleration is a vector quantity because it is derived from a vector quantity, that is velocity. Acceleration is a vector quantity because it is derived from a vector quantity, velocity. So it is a vector quantity. So acceleration, how will you define? It is a rate of change of velocity. Acceleration is a rate of change of velocity. And that is the definition for acceleration. That is important definition. Acceleration is the rate of change of velocity. Its unit is meter per second. And it is a vector quantity. So these are the basic things you must learn about acceleration. Then there are three types of acceleration. There are three types of acceleration. So acceleration normally represented by A, change in velocity Vf minus Vi, change in time is represented by delta t. So change in velocity is representing Vf, that is the final velocity. Vi, its initial velocity. So change in velocity means final velocity minus initial velocity. Change in time means delta t. This symbol is delta. Delta stands for change. So change in time. This is change in velocity. So Vf is final velocity. Then Vi, initial velocity. So this is the basic equation for calculating acceleration. Change in velocity divided by time. There are three types of acceleration. First is positive acceleration. Positive acceleration. What is the condition for that? Vf should be greater than Vi. final velocity should be greater than the initial velocity. Then only the acceleration become positive acceleration. As from the equation you can see that if Vf is greater than Vi, this difference will be positive and you will get a positive acceleration. So during positive acceleration, what is happening? The speed of the object or the velocity of the object is increasing as time increases. As time increases, the object speed or object velocity is increasing in positive acceleration. In negative acceleration, what do you mean by negative acceleration? The final velocity will be less than the initial velocity. Final velocity will be less than the initial velocity. From the equation it is clear, if final velocity is greater than the initial velocity, this difference become minus. So acceleration become negative. So negative acceleration means the final velocity will be less than the initial velocity. So in the case of negative acceleration, as time increases, the speed or the velocity of the object decreasing, and finally the object comes to rest. So in the case of negative acceleration, the velocity of the object is decreasing as time increases, and finally the object comes to rest. Then the third acceleration is zero acceleration. That means Vf equal to Vi. That means the final velocity is equal to initial velocity. From the equation it will be clear, if Vf equal to Vi, this difference becomes 0 and the acceleration becomes 0. So there are three types of acceleration. One is positive acceleration, negative acceleration and zero acceleration. So zero acceleration means what? The speed of the object remains same. That means as time increases, the speed or velocity of the object is same in the case of zero acceleration. So these three things you can understand when you drive a vehicle. If you press the accelerator down, it is positive acceleration. That means speed of the object is increasing as time increases. When you release the accelerator, the speed of the object starts to decrease. That is negative acceleration. Negative acceleration means as time increases, the speed of the object reducing and finally comes to rest. Then zero acceleration means what? We are keeping the acceleration steady. We are not changing. We are not moving down or moving up. So the accelerator remains same there. Okay, it is not moving. So when you check the speedometer, you can see the speed of the object remains same as time increases. So that is zero acceleration. So in zero acceleration, the speed of the object is a constant. In a positive acceleration, the speed of the object is increasing. In a negative acceleration, the speed of the object is decreasing, and finally it can come to rest. So these are the different types of acceleration, and this is the basic equation for calculating acceleration. So acceleration is a common term we are using it. You are hearing that accelerate the vehicle, give acceleration. So this is a common word. So acceleration relating with the velocity or speed. It is the rate of change of velocity. That is the acceleration, and there are three types of acceleration.